one, we have Dylan, Chief Architect, Senior Tech Staff Member, IBM Event Automation at IBM. He will be talking about the API management for an asynchronous world. Thank you.
Thank you to API Days Hong Kong for inviting me to speak to you today about API management for an asynchronous world. My name is Dale and I'm the architect for IBM's Event Automation, and my goal for this talk is to encourage you to think about applying what you're already doing with API management to the event-driven parts of your architectures. I'm going to start by level setting what I mean by API management, because I don't want this to be specific to any individual vendor's implementation. Instead, I'm talking today about API management in the abstract. I'm talking about API management as a discipline. So I'm going to start by defining what I mean, the aspects that I see as being the most common across different vendor implementations. Now, obviously, it's going to include some kind of API gateway. Our back-end API servers are decoupled from the applications that are consuming those APIs, and they're decoupled by going through a gateway. That gateway is responsible for routing the API requests to the correct implementation server. Now, the other specific functions of an API gateway does vary, but the decoupling that they enable is the key bit. The consuming applications don't need to know where the back-end API servers are, and they wouldn't be impacted if those API servers had to move or change, as long as the gateway continued to route requests to the right place. Now, other than routing, common functions of API gateway include things like security, enforcing access to the APIs, making sure that applications can only invoke the APIs that they're entitled to. Other things they'll commonly do will include things like translation or transformation. Maybe some old API server is returning API responses in an outdated format or schema. Now, rather than have to update all of those new applications to handle those old schemas, the API gateway could handle that, automatically rewriting the API responses before returning them to the application, transforming those responses into a current appropriate format. And there are other things it can do too, like maybe filtering. Maybe the gateway can mask out sensitive fields in the API responses that the owner of the API doesn't want to share. There's also a need for the owners of the backend APIs to be able to configure all of this. So there's often some kind of API manager where they can document and describe their APIs. Again, implementations will vary, but typically the owner of the API is likely to want some kind of lifecycle management. They're going to want a way of defining new APIs in some kind of draft state before they're ready to share, and similarly they're probably going to want some kind of archived or deprecated state for APIs that they want to withdraw. The API manager can also include some kind of policy management, letting them define who should be able to see their API, whether or not some kind of approval is needed before a new consuming application is allowed to access the API, and so on. It might include some kind of throttling or rate limiting, defining how much an application is allowed to use an API. And they'll probably want some kind of analytics. They're going to want to see who is using their APIs and how much they're using them. There's typically some kind of access management that will include them being able to revoke access to specific applications, all without impacting other consumers. And finally, there needs to be some kind of developer portal or catalog, a way for developers of those consuming applications to discover what APIs are available and to get the details they need to write their applications. Ideally, this will include some kind of self-service sign-up, a way for those developers to register for access to an API that they discover and to create all the credentials they need without having to go and find or talk to the owners of those back-end API servers. So this is what I mean when I say API management. But what I want to talk about today is how all of these aspects can be just as useful and just as valuable if we bring them across to the asynchronous world. Now, what do I mean by the asynchronous world? I'm talking about our event-driven applications and solutions. I'm talking about applications that put messages on queues or that publish messages to topics. Now, those queues and topics could be provided by message brokers, things like ActiveMQ, or they could be provided by streaming event platforms like Apache Kafka. And I'm talking about those consuming applications that want to receive these events or messages. We use event-driven architectures to enable more responsive, more real-time applications. And my point for today is that the API management discipline can help us to facilitate this. All of this can start by introducing something like an API gateway, an event gateway, something that plays that role of a gateway, but in a way that makes sense for asynchronous event protocols. Now, it has to play the same kind of role as an API gateway, decoupling those consuming applications from the specific details of the backend message and event brokers, routing the traffic to the appropriate queues and topics. It should enforce security. It should ensure that applications can only access the queues and topics that they're allowed to. It could perform translations and transformations. Maybe it rewrites those old messages that were produced to topics in old, outdated formats, so that new consuming applications don't need to be adapted to handle those old schemas. The gateway could transform the messages using new payload schemas. And maybe the gateway could perform transformations to mask or remove message fields and properties that are private or sensitive, allowing the owner of that back-end topic to choose which bits of the messages and events they don't want to share. Perhaps the gateway could even selectively filter out entire messages where they contain some specific sensitive data. We'll also need something like an API manager, but for event endpoints. We'll need something that allows the owner of those topics and streams of events to manage and define how they should be shared. They'll need somewhere they can document and describe their topics and the messages that are on them. They'll need somewhere they can manage the life cycle of their topics, where they can start to document their new topics in a draft state, where they can publish them when they're ready, and where they can deprecate or archive older topics that they want to withdraw. They'll want somewhere that they can manage access to their topics, where they can specify who can see that their topic exists, who should be able to sign up for access to consume the events on their topic, whether approval should be needed, and so on. Maybe even to selectively revoke access to particular applications that they don't want to be consuming events on their topic. And maybe somewhere where they can review how their topics are being used, how many applications are consuming the events on their topics, whether or not those apps are keeping up with the rate of events published onto the topics, where they can check which of their topics are the most widely used, and which topics perhaps aren't being used at all. And finally, they'll need that developer portal or catalog, somewhere that the developers of consuming applications can discover the queues and topics that are available within their enterprise. As before, ideally this would be something that enables self-service access, so developers can create the credentials they need for their applications to start consuming events from these queues and topics, all without needing to contact the owners of the topics or producing applications. They might also want some kind of analytics, maybe about the topic itself, like seeing how frequently messages are being published to that topic, or maybe about the consuming applications that they're running, such as monitoring if their application is keeping up with the rate of events being published to the topic. My point is that everything we're used to with API management could in time be extended and enhanced to include streams of events. My point is that if we think of our message queues and our topics as being just another form of API, an asynchronous API, then we can support much wider and more pervasive adoption of event-driven architectures. But although they have so much in common, there are some aspects about events that are a bit different, that need to be handled a bit differently. So before I finish, I want to highlight a few examples to get you thinking. Firstly, I talked about the value in documenting and describing our streams of events as we do our APIs. High-quality developer documentation is essential for adoption of APIs, and that's no different with topics and events. To enable developers to create the responsive, event-driven applications we want, they're going to need decent documentation. It should be clear, it should be easy to understand. It should be agnostic of any particular messaging technology or protocol. If possible, it should be something that can be consumed by tooling, such as code generators. Now, there are different ways of doing this. One way in particular I wanted to highlight was Async API, an open standard that's part of the Linux Foundation. Now, they're preparing for version 3 of the spec, so it is starting to mature. And if you've ever used OpenAPI before, a lot of it will look familiar to you. Structurally, it's got a lot in common with OpenAPI, but it's designed for documenting and describing the usage of asynchronous endpoints, like streams of events, message queues, and topics. I often see that topics with really valuable streams of events are only used within small teams, and often that's because other developers across the enterprise simply don't know that those topics exist. A key value that we can bring from API management is to socialize the existence of topics and streams of events across disparate teams. Doing this can hugely increase the value that companies can get from their existing topics and queues. And it's not just about socializing. That self-service sign-up I was talking about before is so valuable. Because like I said, we say our goal is to enable delightful user experiences through creating innovative and responsive event-driven solutions. Well, the best way to enable this innovation is to make it easier to create these applications, to remove as much of the friction and as many of the barriers as we can. And as I've put on the slide here, innovation is enabled when we make it easy to experiment and easy to explore. Letting someone discover that a topic exists, giving them all the information they need to be able to access it, and to let them create whatever credentials they need, all through a self-service portal, doing that can be truly transformational. But enabling that needs a special kind of gateway, because asynchronous protocols are not the same as synchronous HTTP APIs. They behave differently, and they need a gateway that can handle that. Going back to this picture from earlier, an event gateway needs to be something that enables seamless communication between a consuming application and a back-end message broker or streaming service. To explain the kind of thing that we think an event gateway needs to be able to do, I need to give you an example of an event protocol. Now for today, I'm going to use Apache Kafka as an example, but all message brokers and event streaming platforms are going to have similar protocol nuances. Imagine a Kafka topic. It's been split across a few partitions to enable the kind of high-performance parallel processing that Kafka is famous for. Now imagine I've got a developer called Alice. Alice wants to run an application to process the events on this topic. To keep up with that stream of events, maybe she runs 2 instances of her application. And to let Kafka know that these instances are both part of the same logical application, she gives them both the same group ID. Kafka will automatically distribute the topic partitions accordingly. Roughly 1/3 of the events on the topic will go to the first app instance, the remaining 2/3 will be received by the second app instance. Now Alice doesn't need to do anything in particular to make this happen. It's baked into the Kafka protocol. It's how Kafka applications work. And when Alice's colleague Bob writes a different app to process events from the same topic, he needs to make sure he uses a different group ID. So let's say he goes with the group ID B for Bob. Maybe he runs 3 instances of his app, and again Kafka will sort all of that out. Each of his app instances will receive roughly 1/3 of the events on the topic. Now doing this only works when Alice and Bob can coordinate. Now if they're in the same team, this is fine. They can agree between themselves what they're going to call their apps and what group ID they're going to use to make sure that they don't clash with each other. But that doesn't work in an API management world, where Alice and Bob are in different teams, where they not only don't communicate with each other, but they've never heard of each other. Imagine Alice and Bob both independently discovered the same topic in the catalogue. They both independently, separately decided it could be useful for their own separate applications. And imagine they then both coincidentally and unwittingly give their applications the same group ID. Well, if the event gateway wasn't a proper gateway, if it was just a naive proxy, passing requests back and forth between the event brokers and the applications, you could end up with something like this. The Kafka cluster would assume that all of these instances were part of the same overall application. It would distribute the events from the topic amongst them. So maybe Alice's app instances would get 2/3 of the events on the topic. Now, as far as she'd be concerned, her app is receiving events. She might never even notice or realize that her app is missing out on some of the events. And poor Bob gets it even worse. One of his app instances is getting around about 1/3 of the events from this topic. The other two never receive anything at all. And again, he might also never realize that this is happening. But both of their applications are producing invalid, incomplete results as a result of this. My point is that an event gateway needs to be more than just a proxy. It needs to do more than just route connections. It needs to be aware of the underlying protocol. It needs to be able to enforce isolation so that any new application can't impact the other applications created by other developers and other teams. And to be able to do this, it has to rewrite the communications between the apps and the back-end event protocols, those back-end event brokers, to ensure this isolation. I'm going to give you another example of this. I talked before about the flexibility that API management can bring, decoupling those consuming applications from the specifics of the individual back-end event brokers. So maybe you start out with a single Kafka cluster that has all of your topics. And then in time you decide you later need to split this into 2 separate clusters, dividing the topics between them. Now, if all of the connections are being made through an event gateway, then by updating the gateway to route traffic accordingly, this kind of flexibility can be achieved, enabled without needing to make changes to the individual consuming applications. Allowing you to manage traffic in this way, in a way that's independent of your current back-end event architecture, and to do this without disrupting consuming applications, that is the goal. The developers writing these innovative new event-driven applications shouldn't need to worry about, they shouldn't need to care about the details of your event infrastructure. But again, to make this possible requires an event gateway that does more than just naively proxy connections. To explain why, I'm going to give you another example, and again I'm going to use Apache Kafka for this, but you could make similar points about any kind of messaging or event platform. Imagine you've got an application that wants to consume messages from a topic on a Kafka cluster. The application doesn't know which of the brokers in the cluster, because Kafka is a highly distributed system. A Kafka cluster is made up of multiple brokers, and the application doesn't know which of these brokers is currently hosting the topic leader. And I say currently because with Kafka this can change over time as things get moved around. So the first thing the application is going to do is to connect to one of the brokers in the cluster at random. It makes what's called a metadata request. Essentially it's saying, I want to consume from topic X. Where is that topic currently hosted? And that broker is going to respond with the address, the host name and the port number of the broker that's currently hosting the topic. So the application can make a new connection directly to that broker and start receiving events from that topic. In an API management world, we don't want the application to connect directly to brokers. We want that decoupling. But to enable this, we need an event gateway that understands this protocol. Because again, if it's just a naive proxy, if it just passes on connections, if it just routes the traffic, you could get something like this. The application would make that metadata request. I want to consume events from topic X, a request that would be routed to some random broker in the cluster. That broker would respond with the connection details of the actual broker that hosts the topic. And if the proxy passes that response on as is, the application will use that to make a connection directly to the real broker, bypassing the proxy for the remainder of the communication, removing that proxy's ability to do any of the things that I've been talking about, enforcing access, applying policies, performing filtering, measuring usage and analytics, and so on. To act as an event gateway, you need it to not just route traffic, but to rewrite the requests and responses that flow between the apps and the back-end event brokers at a protocol level. So when the application makes its initial metadata request, that can still go to a random broker. But when the broker responds with the address of the broker that hosts the topic, that response needs to be modified, to be rewritten before it's returned to the application, so that it's telling the application to continue connecting through the gateway itself. The initial connection flow is just one example of many. Throughout the lifetime of the connection, from a client application to a Kafka cluster, there are so many other things like this that the gateway needs to handle. Understanding the specific event or messaging protocol in sufficient depth so that it remains in front of the event brokers to enable that decoupling. But it has to do this in a way that's transparent to the consuming applications. As far as the applications are concerned, they're just talking to an event broker. Think of the way that your HTTP client applications can never tell when they're talking to an API gateway. They can't tell that apart from a direct connection to a back-end API server. Well, the same should be true in the event-driven world. Our event-driven apps shouldn't be able to tell an event gateway apart from a direct connection to a message queue provider or an event broker. Only once you've got that can you really enable the sort of decoupling that I'm describing. We see API management evolving into this space. We see the evolution of API management bringing a huge potential for enabling new event-driven applications by making it easy for the owners of topics and streams of events to share them across the enterprise as we've been sharing APIs for years. We see the evolution of message queues and streams of events and topics as becoming other forms of APIs by reusing the same kinds of techniques that we've been used to with API management for years. So finally, I want to thank you for your time. I've got my contact details at the address at the bottom of my final slide here. So if you've got any questions or thoughts about any of the things that I've said here today, please do get in touch. I'd love to hear how you see the role that API management is going to play in the adoption of event-driven architectures. I think we're just at the start of this journey, and I'd be fascinated to hear your perspective. Thank you for listening.
The API Connect Hong Kong 2023 conference is powered by bNovelty Limited. Check out more API-related education content on bnovelty.com or apidays.hk for more information.